Okay, so my name is Yvonne, and I am an AI engineer. And yes, I am talking about BERT today. So let's start. Okay, so let's start. I'm going to share my screen.
Yeah, you can share your screen.
Okay. Can you see my screen? Can you see it?
Yeah, you can see it.
Yes, so it's harnessing BERT's potential, transforming NLP models with unparalleled impact. This is basically just BERT and NLP. So before we even get into it, we must understand what these terms mean. So what is NLP? NLP means natural language processing, and that is basically making a machine learning model speak or understand human language. They understand machine language, but now NLP tries to make a machine learning model understand and communicate with humans. So before we go deep, we must understand that human languages are sequential. As we speak, we are speaking in sequences. Like right now, I am speaking in sequences. That's why I am making sense. If I say something like, I can't come, I have made sense because I have spoken in a sequence. But if I say something like, come, can't I don't make sense because I haven't used the correct sequence. So now let's get into it. What is BERT? BERT means bidirectional encoder representation for transformers. This is a machine learning framework for NLP that is open source. So BERT is framework for NLP, and it is also open source. Anyone can contribute to it, but is intended to assist computers in understanding the meaning of ambiguous words in text by establishing context from the surrounding content, but is used to help computers understand context of a word. For example, the cat came. BERT will understand the context of that cat in a sentence. Okay, BERT is a type of a large language model, LLM. LLM are, okay, we will meet LLMs when we go to the next slide. Let's just know that BERT is a type of LLM and it was developed by Google. LLM stands for large language model, as we have seen, and they are used mostly to create things like chatbots. Like, for example, ChatGPT, that is an LLM that was used to create it. Yes. So LLMs are a type of advanced natural language processing models that learns rich representation of language by training on huge volumes of data. So LLMs have been trained on huge volumes of data, and then after training them, they can be used to train other models. Like they can be used to train um, chatbot. Yes. So LLMs are characterized by characteristics of these large language models is there is unsupervised pre-training. That means that, okay, in machine learning, there is supervised learning and unsupervised learning. Supervised learning is the kind of learning where you give a machine instructions like questions and then you give it answers. For example, you give it an image and then you give it a label telling the machine that is a cat. You give it an image of a dog and then you give it a label telling the machine that that is a dog. And then that is supervised. Unsupervised is where you just give the machine data and then from the data it makes its own conclusion. For example, you can give it two piles of clothes. One the first pile is red in color, the second pile is blue in color. So what the machine will do, it will divide the clothes into the two piles, the red one and the blue one. It won't know what the red one means and what the blue one means, but what it will know is that all of them, the red ones belong to one pile and the blue ones belong to another pile. I hope I have made sense on the unsupervised learning. So the unsupervised pre-training means that that is how the LLM was trained. And then there is contextual embeddings. Contextual embeddings help the large language models to understand the context. For example, what was done to John was not fair. And then the other sentence is John went to the fair. You see, in those two sentences, fair has been used differently. It means different things. Or, for example, I ate dessert, and then the other sentence, I visited the desert. You see, in those two sentences, the word desert has been used differently, even though it is the same word, it means different things. So LLMs have contextual embeddings. These contextual embeddings help them understand words like that, like desert, the way the desert has been used in those two sentences. And then there is transfer learning. Transfer learning basically means that you take a model that was trained on a certain task, and then you transfer it to do another task. For example, if a model was trained on identifying images of cars, you can take that model and use it to identify trees. You see, that is transfer learning. You have transferred the knowledge it has gained from learning about cars and replaced cars with trees. And then there is scale. LLMs, as we have said, they have been trained on a large, very large data set. Yes, for example, the BERT, it has been trained on so many articles in the Wikipedia, like the whole Wikipedia has been used to train BERT. That is why it is really performing very well. Okay, some use cases of BERT I can say is like the Google search. For example, when you search something in Google, that is BERT you are using. It helps you search. It gives you answers according to what it has found out. That is BERT you are using. And as you know, Google Chrome is the best search engine out there. So that shows that BERT is really performing very well. Yes. I hope up to there you guys have understood me. Okay, so there are examples of LLMs. There is GPT, which has been used to create the chat GPT that we use. There is GPT-2, GPT-3. GPT-2 is free, but GPT-3 you have to pay for it if you want to use it. There is BERT. BERT is open source, as we have seen. That is what the Google search engine uses. Then there is T5. That is a model for text. And then there is Albert and Roberta. Those two are branches of BERTs. There is Albert, a branch of BERT, and Roberta, a branch of BERT. Yes, and then there is the transformer architecture. Okay, so in these LLMs use things called transformers. Transformers, the word transformer came from it in such a way that you can change what it does. For example, you can use it to answer questions and then you transform it to summarize an article. That is a transformer. For example, like ChatGPT. ChatGPT can be used to answer questions and then it can be transformed to summarize a document or to generate other texts. Yes, that is what transformers means. Basically, it transforms. It can transform its usage from one form to another, like question answering, and then from question answering to sentimental analysis. Yes, and then there is the transformer architecture. So these LLMs, basically, because they are used to perform many tasks, they use the transformer architecture. That is why you see that you can use an LLM to, like GPT, you can use it to build question answering models, and then you can use it to build also sentiment analysis models. You can also use it to do things like summarize your documents. You can transform it into different forms. That's because it has the transformer architecture. So what does the transformer architecture contain? It contains, how is the architecture utilized in LLMs? Okay. One, attention mechanism. It helps LLM pay attention to a certain word. For example, we can say, for example, it is an article about Tesla. Yes, let's use that example. It is an article about Tesla. LLMs help LLMs use the transformer architecture to pay attention to that Tesla word, to weigh how is it really important or is it not important. That is the attention mechanism. It is used to weigh how important a word is in a statement. For example, I went to the desert. Desert and I are really important in that statement, but went is not that important. Encoder and decoder structure. The encoder and decoder structure in transformer architectures is applied in LLMs in that encoder takes the input that you give it, like words and statements, and then after the input that you give it, it transforms those inputs to to numbers. Let me use vectors. It transforms the inputs to vectors. For example, we all know that computers do not understand the language that we speak. The language must be transformed to numbers for it to understand. Now that is the work of the encoder. It encodes the statements that you give it or the document that you give it to vectors. And then after encoding, it reads through it and it does its work. And then the decoder now comes at the output end. So the input end, there is the encoder, and then the output end, there is a decoder. So the decoder helps to helps to change the numbers into now statements that we can understand, because we all know if a computer outputs for you numbers, you won't be able to know what that statement means. So the work of the decoder is to make sure that the numbers are converted into a language that we can understand. And then now there is positional encodings. Positional encodings work like this. We have said that language in when I'm speaking through a sequence. Like right now, the way I'm speaking, I'm using a sequence. So positional encoding ensures that the model understands this sequence that I am using. It ensures that the model understands the correct sequence. It ensures that the model knows when I say mm, can't come I, that's wrong. You see, that's what positional encoding does. It preserves the sequence of the words that you give it. Then there is normalization. Normalization helps to train a model. Normalization helps to improve the performance of your model in all models. This doesn't apply only in LLMs, it applies in all the models. Then there is multi-head attention. So multi-head attention helps the LLM figure out the how. Okay, for example, the way I have used the word desert in the two statements, like I went to the desert and I ate dessert. So this multi-head attention will help the model figure out that the first desert means that it's a dry place, and then the second desert means that it's dessert she was eating. It is food. Yes. So that is the transformer architecture. That is the architecture that these LLMs use. And this is also the architecture that BERT also uses because BERT is an LLM. So now let's get into BERT. There are two variants of BERTs. There is the base BERT and large BERT. Base BERT is we can say it's a smaller version of BERT. It has 12 encoders. That's base BERT. That's base BERT. It has yes, only 12. And then there is the large BERT. Base BERT can be used for small documents, but if you have a very large document that you want, for example, let's say you want to build a model that summarizes your documents, you can use base BERT to build that model if you have a small document. But if you have a very large document, you should use the BERT large. As we have said, BERT was trained on the entire Wikipedia and was trained for 1 million steps. That is why it is performing very well, because you can imagine how many articles are in the Wikipedia. There are so many articles in the Wikipedia. So BERT was trained on that whole thing, and then after training on the first round, it was trained again and again and again for 1 million steps. And then BERT was trained on MLM. That means masked language model. So MLM means masked language model in such a way that I can say that, okay, I was crying and I mask tears. For example, I have this statement: I was crying and tears were falling out of my eyes. And then I decide to mask tears and let BERT guess what I'm trying to say. Like, I was crying and then dash were falling from my eyes. You see, that is what masked language model means. It masks a word and then lets the model guess what that word means. And then there is NSP, which this means next sentence prediction. Like, I was crying, and then you let it predict the next sentence, like tears were falling out of my eyes. That is what BERT was trained on, and that is why it is performing very well. For example, when you go to Gmail and you start typing, it sometimes autocompletes for you, or it gives you suggestions on how you want to autocomplete your statement, or you want to complete your statement. It does that because it was trained like this. It knows that because words were masked, and then it predicted that when you cry, tears fall from your eyes. When you say thank you, it also tells you are probably going to say kind regards. This is how it was trained. Okay. Uses of BERT. There is name entity recognition, like the way we have said desert and desert. It knows This means it knows what the first desert means and what the second desert means. Name entity recognition also means that it recognizes a name. For example, if I pass my name as Yvonne, like Yvonne was happy, it will recognize that Yvonne is a noun. Was It recognizes parts of speech, like I am coming. I is a pronoun. Am is whatever. Coming is a verb. It recognizes that. And then there is, so if you want, for example, you have a document and you want to filter out the nouns or the names of people, you can use this name entity recognition. Then there is next sentence predictions, as we have said, like Gmail, when you write your mail, the way it auto completes the statements for you, that is next sentence predictions. And then there is long text classification. For example, you have the way, okay, for example, the way we classify emails, or Gmail classifies emails as spams and not spams, that is long text classification. They read the whole email, and then there are some words there that show that this email is a spam, and then there are other words in the email that shows that this email is not a spam. So that is long text classification. And then there is question answering models. Like, have you ever gone in a system, have you ever gone in the facts frequently asked questions, or have you ever visited a site and then you are talking to someone, okay, you want help, and then in that help platform, when you type, it answers directly. When you type, the person answers directly. That is basically an AI being used to answer your questions. It has been programmed like that. Text summarization. If you have a long document and you don't want to read it all, you just want to read the important parts in that document, you use text summarization. Then there is sentiment analysis. Sentiment analysis is used to analyze whether people liked something or not. We can say sentiment analysis is used to rank items. For example, this item was very good. I really didn't like this item. It was very bad. That is an example of sentiment analysis. Those are the users of BERT. And then the last thing, advantages and disadvantages of BERT. There is advantages, contextual word representations. BERT can understand the context of something. You can give it a story, it will read that story, and then it will understand the context. And from that story, you can ask it questions and it will answer your questions. Then there is pre-trained knowledge. It has been trained on so much that when you want to use it for a certain task, it becomes easy. For example, you want to use it to you want to create a model that can help users write you want to create a model that can help users write articles on machine learning, but has a lot of knowledge on machine learning because it knows the whole Wikipedia. So it can help you create that model, in that it will you won't have to train it on the whole knowledge of machine learning, because it already has knowledge. You'll just give it some data and then it will start understanding. Then there is bidirectional mechanism. In bidirectional mechanism, but understands but can be used to understand words in both ways. Okay, for example, a word sitting at the middle of a sentence, like I ate dessert. It understands that it is me who ate, and what did I eat? I ate dessert. It is bidirectional. Then there is transfer learning. It transfers the model. It transfers the knowledge that it has to other things. For example, we have said you can use BERT to summarize documents also. You transfer the knowledge that the BERT has learned from one thing to another thing. Then there is contextual understanding. It understands the context of what you're saying. Disadvantages, it takes a lot of computational resources for you to run BERT. Like, for example, right now I can't run a program for BERT because I need to use another computer which has a GPU and also has a very high RAM for me to run a program that runs BERT. It needs a large amount of data to train, even though we have said it has been trained on a lot of data. If you want to train it on a certain area, for example, you want to train it on farming, you will need also a large amount of data to make BERT understand you. Yes, so that was all. Do you have any questions? Do you have questions? If you have questions, kindly ask.
Thank you, Yvonne, for taking us through this session. I really enjoyed it and I've learned a lot. I think this is my first time learning things related to BERT and maybe NLP. So I'll let maybe if anyone has a question, you can ask Yvonne and then she can answer you.
You guys are not even interested to know how to apply BERT. Like which libraries do you use? Okay. Munyao,
Hello, Yvonne.
hello.
How are you?
I'm fine.
Oh, I'm also fine. I'm happy to have joined the space.
Yes.
Maybe I'm a bit unfamiliar to the whole group, so I'm Munyao. I'm a master's student.
Yes.
I'm pursuing natural language processing.
Okay.
So what I've been presenting, I'm a bit familiar with. So I'm so happy. I'm so happy you have ventured so much into these transformers and in particular BERT.
Yes. I'm trying.
The area I'm researching on, you actually mention it in your applications of BERT model. My thesis
Where?
is on text summarization.
Mm-hmm.
Maybe after the call, I can try to share my thesis with you because I've seen you're a bit knowledgeable in this NLP area.
Yes. Feel free. I'll
Yeah,
drop you my number or my email.
no
Yes.
problem.
So.
So my thesis is all about trying to enhance the performance of these large language models
Mm-hmm.
in the sense that I'm trying to address the disadvantages that you mentioned. That are some of my research problems, but
Yes.
your list was not exhaustive because I'm also
Yes.
trying to address the issue of content hallucination.
Yes. I know it was not exhaustive. I
Yeah,
used a bit for people to understand. You know,
definitely.
yes, because not everyone has dived that deep.
But
Okay.
then we can try to have a sit-in
Mm-hmm.
and see how I can even further my research.
Okay. Okay.
Uh,
No problem. Okay.
with that, I don't think I have any other issue. Maybe just to front a question on, have you interacted with the recent nose arms model or Llama 2 from Meta?
No, not yet.
Okay, no problem.
Okay.
Okay, thank you.
So there is, what frameworks do you use, PyTorch or TensorFlow? So BERT is open source, and BERT you can find it is for Google. So one, obviously, TensorFlow is there. And then there is something called Hugging Face. If you don't have TensorFlow and you want to use PyTorch, you have to use it with another library called Hugging Face. Hugging Face is our is our wide, it's worldwide, it's everywhere. And Hugging Face is where you get transformers. Hugging Face has a lot and a lot and a lot of transformers. So if you want to venture into into NLP, you have to know things like Hugging Face. And when you use Hugging Face, you can use you import transformers, and then from those transformers, now you can import the model that you want. Yes.
Okay, Yvonne.
Yes.
Okay, you also mentioned something on you cannot implement BERT on your laptop because of memory requirements and computational resources.
Yes, it takes a really long time to implement. You can use Google Colab, yes, but
Uh-huh.
I think it's a little bit limited so far, according to what I have seen.
Uh,
It lags. Sometimes it lags. It depends with the amount of data you have, and it also lags. Maybe
do we
you pay
do we
for
have
the
Do we have any other alternatives? Because at the moment, what I'm using is Google Colab, the Pro version. Now I'm paying for it
Oh,
monthly.
yes. You see, now that pro version can run. Even I use the pro version. But now I'm talking about people who don't have access to the pro version. You know, the pro
Oh,
version
exactly.
is, yes, the pro version is more advanced compared to the
Right.
normal one. Yes.
Because at the start, I was using the unpaid version, and what I was usually getting is the out of memory error.
Yes,
I'm leaving my model to train overnight, then I wake up to out of memory error, which was really exhausting.
yes, even I encountered the same problem. I tried running it on my computer crashed. So I tried using Google Colab, and then I got the out of memory error, or I get the Google Colab telling me my progress has
Processor
not
is
been
stopped.
saved. Yes, my
Oh,
progress has not been saved. It hasn't
and
saved.
maybe another question, Yvonne, do we really have any other alternative outside Google Colab?
I can say Google Colab is the best. Or maybe you upgrade your computer and use your GPUs. You can use GPUs.
Because the institution I'm doing my master's in was providing Kenneth, what do I call them? Kenneth servers.
Oh, yes. Even a
So
server can work. But
I
I'm
tried to
talking,
run my models through the Kenneth provided servers, but it was taking almost 4 days for one epoch to complete.
yes. So
Mm.
you have to have a GPU to run something like that.
Yeah, sure.
Okay. I can see Hilary Kavagi say, kindly, can you assist me on embed a model on a web page? Yes, you can use Flask to embed a model. Do you know machine learning, Hilary? Hilary, please unmute. Okay, so if you are learning machine learning, then you can also learn how to use Flask. Okay, no problem. You can also learn how to use Flask to deploy a model. You can also do that and you'll see. But you can reach out to me also and I will assist you in any way that I can. So is there anyone else with a question? I'm sorry, today I don't have a practical because I have to run it on a GPU and I don't want to start that right now. Okay, let me give
Uh,
my ear. Yes,
okay.
is there anyone?
Perhaps a
Hello?
comment. Hello.
Yes.
A comment, perhaps. I'm sorry. I won't say this has been quite an informative session. I am just finding my footing in data science and machine learning towards AI, and the explanation using examples has been quite comprehensive and has definitely helped me get a nice foundation to build upon. Thank you.
Okay. Thank you so much, John. Yes. So that was all from me. I had planned my session to last for 1 hour, and yes, it has lasted for 1 hour. Thank you for listening to me. Yes, thank you.